An organic compound with a vapor density of 56.5 has the following percentage composition: carbon 53.1%, nitrogen 12.4%, oxygen 28.3%, hydrogen 6.2%. The molecular formula of the compound is dash. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that so as not to miss out on more videos like this. Let's proceed. The question above has to do with the molecular formula of a compound, and before we can predict the molecular formula of a compound, we need to know the empirical formula of a compound. And this is because the empirical formula serves as the formula which shows the lowest number of moles of the compound. That is, it shows the least possible number of atoms of each element present in a compound. In the question above, we have been given the percentage composition of each of the elements. We do not know the number of atoms. We do not know, maybe we have 2 atoms of carbon, 3 atoms of nitrogen, and the likes. So that's the reason we need to calculate the empirical formula of the compound first. And in calculating empirical formula, for each element, we need to know the exact number of atoms present. Then we can merge it together to have our formula. The first thing we'll be doing is to determine the number of moles of each of the elements. Then from there, we can find the lowest possible ratio, that is the lowest whole number in which each of the elements are combining together. Another thing is that we can decide to solve for each of the elements one after the other. That is, calculate the number of moles of carbon, calculate that of nitrogen separate, then oxygen and hydrogen as well. But to save time, we'll be doing that together. We'll be doing it simultaneously. We'll be having it in a tabular form. So I have the elements. I have carbon, I have nitrogen, I have oxygen, then I have hydrogen. Those are the 4 elements present in a tabular form. So the first thing to do, since the aim of this is to get the number of moles of each of the elements, that means from the formula for calculating number of moles, that's mass over molar mass. Since we are given the composition of each element in percentage, then we'll be taking the whole of the compound, that is the mass of the compound as a whole, to be 100%. So now if the whole mass is taken as 100%, definitely carbon, which has a composition of 53.1%, can then be said to have a mass of 53.1 grams. So now let's start. On this side, we'll be having percentage composition by mass. Now for carbon, we have 53.1. For nitrogen, 12.4. For oxygen, we have 28.3. And for hydrogen, we have 6.2. And if we sum each of these together, we'll be having a total of 100. So let's proceed. Now we've stated the percentage composition by mass of each of the elements. The next thing to do now is to state the atomic mass. Don't forget formula for calculating number of moles, mass over molar mass. And in this case, since it is not a compound, we are dealing with each of the elements, then we'll be using the atomic mass of each of them. So now our formula for moles will then be mass over atomic mass. So now here we have for carbon. Now on this side, I will be noting that relative atomic mass. Then my unit in grams per mole. So here now percentage composition by mass, I can have my unit as grams as well. Now for carbon, we have carbon to be 12, and nitrogen is 14, Oxygen is 16 and hydrogen is 1. Where this is expected to be known of us because it's not given in the question, and there will be questions like that in which you won't be given the atomic mass of the elements, so we are expected to know that. Thing to do now is to calculate the number of moles of each of the elements. Now here I have 53.1 divided by 12, 12.4, that is mass over molar mass, divided by 14, 28.3 divided by 16, and 6.2 divided by 1. 53.1 divided by 12, we have 4.425. 12.4 divided by 14, that is given to be 0.886. 28.3 divided by 16 for oxygen, that is gotten to be 1.769. And for hydrogen, 6.2 divided by 1 still gives 6.2. Now we've gotten the number of moles. This won't be the end. We need the least number of moles. Now that is, we need to know the simplest ratio in which they can combine. And to get the simplest ratio in which they can combine, we'll be dividing each of the elements by the smallest. So here then I will say divide by the smallest. The smallest here now is 0.886, so we'll be dividing by the smallest. So I have 4.425 divided by 0.886. Yeah, 0.886 divided by 0.886. Yeah, 1.769 divided by 0.886, and here also 6.2 divided by 0.886. Dividing this, we have 5. This gives 1. 1.769 divided by 0.886 gives 2, while 6.2 divided by 0.886 gives us 7. So the simplest mole ratio is in the ratio of 5, ratio 1, ratio 2, then ratio 7. Now we can conclude that we have 5 atoms of carbon present in the compound, 1 atom of nitrogen is present, 2 atoms of oxygen is present, and 7 atoms of hydrogen is present. So for the arrangement now, I'll be writing CNOH. CNOH, since it's an organic compound, the carbon and the hydrogen will come first before the other elements. So I have carbon first with subscript of 5, and hydrogen subscript of 7, the oxygen subscript of 2, and nitrogen. Nitrogen is 1, but the 1 will be significant. So I have C5H7O2N, and that will be the empirical formula of the compound. So now starting here now, then I'll say empirical formula equals C5H7O2 and N. Now this is just the first part to the question. Don't forget we are being asked to calculate the molecular formula and we are given the vapor density. Now to get the molecular formula now, having gotten the empirical formula, we need to know the empirical formula mass of the compound. The first thing, we need to know the molecular mass of the compound as well. So from here now, I'll be calculating the empirical formula mass of the compound. So I have that to be equal to 5 atoms of carbon is present, so I have 5 times 12. 12 is the atomic mass of carbon, plus 7 times 1 atomic mass of hydrogen, plus the atomic mass of oxygen is 16, and we have 2 atoms present, so that will be 2 times 16, plus for nitrogen, atomic mass of nitrogen is 14, and we have 1 present, so just have that as 14. So here now I have 60 plus 7 plus 32 plus 14, which gives a total of 113. My unit in grams per mole. For the molecular mass of the compound, we'll be using the formula that says molecular mass equals 2 times vapor density. In some cases, the molecular mass would have been given in the question, but here we are not given the molecular mass. Instead, we have the vapor density, and that's why we are using this formula to get the molecular mass. So now the vapor density from the question is 56.5. So then that means the molecular mass will now be 2 times 56.5. Calculating this, we have 113. And our units will be in grams per mole. Don't forget that the molecular formula is a multiple of the empirical formula. Simply put, empirical formula makes up the molecular formula. This leads us to the relationship that says molecular mass equals empirical formula mass multiplied by n, that is in brackets of n, where n is a whole number multiple. Since we do not know the molecular formula yet, but the mass can be determined and we need to know n. So the first thing to do is to put the relationship as considering the masses of both the molecular formula and the empirical formula. That's why we have the relationship to the molecular mass equals empirical formula mass multiplied by the whole number multiple. So what we need here now is to get the whole number multiple, that is how much of this will be present in the mass of the compound. N is the unknown here. We've gotten the molecular mass, we've gotten the empirical formula mass, and n remains unknown. Since n is the unknown, then I can say n equals molecular mass. I'm making n the subject here, divided by empirical formula mass. And this equals, from our calculations, we have molecular mass to be 113 units grams per mole, and the empirical formula mass is also gotten to be 113. So this is equal to 1. This has to do with the mass alone. Now coming back to the formula now, since that is the main thing we are being asked to do. So we have molecular formula equals empirical formula into brackets of n. Here now we've gotten n, we have empirical formula, but molecular formula remains unknown. The molecular formula will now be given as, the empirical formula we got from previous calculation is C5 H7 O2 then N. everything in brackets of n. Here now when we've gotten n to be 1, so opening this one now means that we'll be multiplying each of the elements present here, that is the subscript of each of the elements, with the number outside the brackets here now. So now 5 times 1 is still 1, C5. Hydrogen now, H, we have 7 atoms present, 7 times 1 is still 7. Oxygen now, 2 times 1 is still 2. Nitrogen, 1 times 1 is 1, or the 1 remains insignificant, so we have N there. So now this can then be put to be the molecular formula of the compound. So the molecular formula is C5H7O2N. In some cases now, if you notice, the molecular formula is same as the empirical formula. This is because the multiple we got is 1. In some cases, N can be 2, N can be 3. So if N is 2, definitely the molecular formula won't be the same as the empirical formula. And with this, we've come to the end of the solution to the question. From what we did here now, we can conclude that the molecular formula of the compound is C5H7O2N. That will be all. Do not forget to subscribe and click on the notification bell so as to be notified as soon as new videos are being posted. You can also leave your comments in the comment section below, and like and share the video as well. Thank you.